Hello everyone, and once again welcome you back to the course on kinematics and theory of machine. So in this lecture we are going to discuss basically about the mobility of mechanisms, and we are going to see how to find out the degree of freedom for different spatial as well as planar mechanisms. Along with that, towards the end of this particular lecture we are going to discuss about the inversion of Pourbaix. So first, coming to the mobility of mechanism. So now we already know this all those mechanism whatever we have, okay, whatever we synthesize, it serves certain purpose, and all those mechanisms, in all those mechanisms, the different links which are joined with various joints, types of joints, they have got certain constraint type of relative motion between them. So what basically is expected that whenever we are going to give certain input, okay, and we should expect, we should get certain desired output motion. Okay, so now based on that only the concept of degree of freedom, etc., or you can say the mobility in case of mechanism, it has come. Now, expressing the number of degrees of freedom of a linkage in terms of the number of links and the number of pairs of connections of different type, this particular phenomenon, this particular analysis or working is known as the number synthesis. In number synthesis, what we do basically, we find out the degree of freedom of this particular linkage, and for finding out it, what are the different types of things or different consideration we do, we consider or we find out it in terms of the links and number of pairs of that particular linkages. So we already know about degree of freedom. Generally, from your previous class, you know that degree of freedom generally these are kind of nothing but we in terms of some independent coordinate system or some independent coordinate that will be required, number of independent coordinate for completely expressing some positions and all. Generally we discuss with respect to that. Okay, in physics, maybe high secondary physics and all, class 11 12 physics, you have discussed like this. So different independent coordinate or different independent type of motions in our case. Okay, so now here this if we are talking about these various kinds of you can say mechanisms and all, so we already know the basic building blocks for this mechanism, they are nothing but the links, or also we call as the members. Okay, so now these are all kind of rigid bodies only, we already know. And now if we forget about the linkages and all all those connections and all, and if you consider only a single rigid body which is there in space, okay, and which is unconstrained, that means all the movements are possible, it is not constrained in any direction. That means every all those things, all the type of movements are possible. Then in that particular case it can have six degree of freedom, that means six independent motions it can have. Okay, so considering all those translational as well as rotational motion in three axis, that is the space, we can have 3 degree of freedom. Okay, and now if we come to the constraint, okay, that means if we do the connection of linkage, okay, then what basically happens, if we connect one link with another, then it imposes certain constraint on their relative motion. That means now they are not free to move in all the direction as they desire, just like in the case of unconstrained kind of motion, but now it will impose certain constraint. That means in some ways or other, some movements in maybe some direction it will be constrained or it will not be permitted, that means. Okay, and now if we're talking about a linkage, okay, then the number of restraints, that means limitation, number of restraints is, it can never be zero. That means if it is zero, that means the restraints, that is the limitations, if it is zero, then it means that the joint is disconnected, that means they are not even joined. And if the members are not even joined, how can they form a kinematic chain, and from there how can we obtain a kind of mechanism? So it's not possible. So number of restraints, it can never be zero in case of linkages. Okay, then it will mean that the joint is disconnected, or it can never be 6 also, because in that particular case it will also, it will once again work, it will once again behave like just the case of rigid body. Okay, if it is 6, it is just like a solid body, or it is the joint becomes solid. Okay, there is no movement possible, that means all the things are restrained. This all the 6 independent movements which were previously possible are now restrained. Okay, that means the joint is solid. Okay, and there is no use of it. Okay, if there is not even any possible relative motion, what is the use of it? There is no use. Okay, so that's it. So now there is a formula. Okay, so to find out the degree of freedom of a mechanism in space, this you must remember, this particular relationship is valid for mechanism in space. So how can we find out? F, that is the degree of freedom, equal to 6 whole into n minus 1 minus 5p1 minus 4p2 minus 3p3 minus 2p4 minus 1p5. Okay, so here what basically is this? Okay, F denotes the degree of freedom. This n is nothing but the number of links which is there in the mechanism. So p1 p2 p3, they are something like, p1 is number of pair which is having 1 degree of freedom. Similarly, p2 is number of pair having, it should be 2 degree of freedom, and so on. Okay, similar p5 and all. Okay, so this particular relationship is valid only for mechanism in space, that is the special mechanism. Okay, but the thing is, from your previous knowledge we have already seen all those our normal slider, your, we can say slider mechanism, or maybe the four-bar mechanism, which are one of the most versatile kind of mechanism. They are planar in nature. That means the points in the mechanism, they move in parallel planes. These things already we have discussed in previous classes. So now, in case of planar mechanism, okay, how can we find out the degree of freedom? So now the whole previous thing, that is the previous relationship, now it can be basically reduced. Okay, reduced to one particular relationship which is somewhat similar to the previous one, but right now, in case of our case, okay, right now we are talking about planar mechanism. Now in this particular time, I just want to go back to the previous case. Okay, how basically we have obtained this particular equation. So in that particular case, what basically happens is, see, it is expected that you already know that unconstant rigid body in space, it has 6 degree of freedom. So if we have n, if n is the number of total number of links, so that means total n number of, you can say, this kind of rigid bodies. Okay, so it is going to give us 6 into n, 6 n numbers of, you can say, your degree of freedom. Okay, but the thing is, we already know a minimum of one. That means one of the uh, you can say link, in case of a kinematic chain, it has to be fixed if we have to obtain a mechanism, right? So that means how many, if one is fixed, total number of total is n. Okay, total number of links is n. Out of them, one number of link is fixed. Okay, that means fixed means it cannot move. So how many movables are there, movable links are there? It will be n minus 1. They are the movable links. Okay, so that's why now it is 6 into 6 is for 1. For one unconstituted body, it is 6 degree of freedom. So now n minus 1 number of movable links are there. So in case of space, it is 6 into this n minus 1. From here it is coming. Okay, similarly, if number of p1, it is number of pairs having 1 degree of freedom. Okay, 1 degree of freedom means what? Only one type of movement. That means the, how many total movements are possible? 6 movements. So 1 degree of freedom means one type of movement. So how many movements are not there? 6 minus 1, that is 5 numbers of movements, it is not there. That's why it is minus 5p1. Similarly, if we are talking about, it should be 2 degree of freedom. Okay, number of pairs having 2 degree of freedom. So in that particular case, it will be, if 2 degree of freedoms are there, that means 2 movements are possible. Other 4 movements are restricted. That's why 4 into this p2. Similarly, if 3 degree of freedom, other 3 are restricted. If 4 degree of freedom, 2 are restricted, and so on. Okay, I hope you have understood. So now in this particular case, we are talking about planar mechanism. So now most of the, as we have already discussed, most of the mechanisms are 2D, like 4-bar or slider kind mechanisms and all. Okay, in this particular case, displacement is possible along 2 axes. Okay, 2D we are talking about, and rotation only about 1 axis. That means wherever it is placed, on whichever uh, you can say plane it is placed, about that plane, okay, perpendicular to it, it can rotate. Now for planar mechanism, the previous expression, it gets reduced to this particular expression. Okay, F equal to 3 whole into n minus 1 minus 2p1 minus p2. Now this particular relationship is known as Grappler's criteria to find out the degree of freedom of planar mechanism, or sometimes this particular person is also sometimes known as Kurzweil equation, okay, or Kurzweil criteria. Okay, now here in just like the previous case, here also n means the total number of links, f is nothing but the degree of freedom. Okay, DOF, p1 number of pairs having 1 degree of freedom. Now for solving problems in the subsequent classes, there is another consideration. So p1 is nothing but the number of lower pairs. If we can directly find out how many number of lower pairs are there in that particular mechanism, we can substitute it for p1. Similarly, p2, it is the number of higher pairs. Okay, so what is lower pair? It is surface contact. Surface contact is there. Similarly, in case of higher pairs, we have this line or point contact. It is either line contact or point contact. Okay, so that's it. So this is how we are going to find out the degree of freedom of planar mechanism. So this particular equation will be very much useful. We will be using it time and again and again. And in that particular case, you should be able to find out how many total links are there in that particular mechanism. For finding out the total links, one by one we will be just numbering the links 1, 2, 3, 4 like that. And in that particular case, what you must remember is the ground links. Those are displayed with hatches and all. Okay, ground links, they are always, or the fixed links, they are always numbered with the same number. If there are in 4 positions, if grounding is there, everything will be 1 1 1 1 only. Okay, all the links will be numbered as one same number. Okay, not 1 2 3 4 4 different links. Okay, similarly, that is you have to remember. Similarly, you should be able to find out the how many higher pairs are there, if it is there. Okay, or how many lower pairs are there. One of the good thing is that in most of the cases in preliminary level, okay, we really most of the times we will not sometimes we may not even have higher pairs in our mechanism. Okay, only if it is kind of pin joints and all. Okay, then there may not even be higher pair. In that particular case, p2 will be no higher pair, means p2 will be 0. Okay, so now we come to the inversion of mechanism, and in that particular case, initially we come for the inversion of the basic type of chain, or you can say that is the forward chain. Okay, so as we already have discussed, that means what is inversion of mechanism. So we know that mechanism from a kinematic chain. How can we find out mechanism, obtain mechanism? We can obtain a mechanism by fixing a particular link. Okay, if we fix a link from a kinematic chain, we obtain a mechanism from it. Okay, now based on how many links are there in that particular chain, okay, that particular fixing of one link at a time can be done in multiple ways. That means if there are four, suppose there are 4 links, okay, then in 4 different ways will be able to fix one link at a time, right? So this is going to give us multiple inversions and multiple mechanisms, you can say. And this particular process of getting various mechanisms, different mechanisms, by fixing one link at a time from the same kinematic chain. Okay, those are important. We have to fix one link at a time, and it should be the same kinematic chain we are working on. So in that particular case, this particular process will be known as the inversion of mechanism. So this way various inversions are possible. Some of this kind of mechanism which we get by inversions, they are useful. That's why this is useful. Now when we were talking about the forward chain, so basically we have got 4 inversions. The first inversion is the coupled wheel of locomotive. It consists of 4 links, and the opposite links are equivalent in length. Okay, so you can see this link and this link. As the forward chain, we already know there are 4 links. Okay, so in this particular case, in this first inversion, so the opposite links are equal in length. That means link 1 and link 3. Similarly, link 2 and link 4, they are of same length. Okay, and this link 1, this one, and this link 3, they work as crank. Okay, crank means they can have this kind of rotational motion. Correct? And that's why as there are 2 cranks, it is double crank mechanism. And similarly, this link number 4, right now in this particular case, it is numbered as 4, it is fixed. Okay, and this link acts as the coupling rod. Okay, And now where it is generally used, this particular inversion you might have seen in the railway wheels. Okay, that means we have got this kind of it in this animation it is evident. Okay, you might have seen this kind of like arrangement in the engine side, in the starting of your particular, you can say, this particular railway tracks, okay, in the locomotive. So what basically happens here, this rotary motion of wheel A will be transmitted to wheel B via this particular coupling. And some advantages are there, that means all the slip etc it is generally minimized. There is less tendency of slip in case of couple wheel. Okay, as both the wheels are coupled, so that's why it is known as couple wheel. And it is not like you should not suppose, depending on your convenience, you may even number this as 1 1 2 3 4. With the numbering there is no issue, but whatever number you give, based on that only you have to it should be reflected here. You should not say like in case of couple wheel of locomotive or in the first in person link 4 is fixed or something like that. Okay, actually everything comes with respect to the figure, whatever nomenclature we have used in the figure, like that only. Similarly, second inversion we have, and one of the example of this particular second inversion is the beam engine. So now what happens in this particular second inversion of slider forward chain, this particular beam engine is the one of the perfect example of use of this particular second inversion. It is also called as crank and lever mechanism. And why generally it is used, it is used to convert rotary motion to reciprocating motion. Now how we are going to convert the rotary motion to reciprocating motion? So here in this particular crank, that means it is here in this case. Okay, it is going to rotate. Okay, the crank is having the rotational motion. Okay, so after that we have the connecting rod here. Okay, this is this. Okay, and we have this particular rocker arm like kind of structure, this particular arm. Okay, this particular arm, okay, which is pivoted here, it is pivoted here. Okay, so because of this pivoting, it is about this particular point it can oscillate. Okay, so now this link tree, which is this has been numbered as link tree, this is number 1 2 3 and 4. Okay, now what basically happens, whatever motion we have, suppose prime movement is here, that means initial motion is here. So as this is the connecting rod which connects this with link 3, and link 3 is pivoted here, which can oscillate about this point C. Okay, and we have this particular frame here. Okay, and we have this particular arrangement. Okay, piston cylinder kind of arrangement. Now because of this particular movement, and this movement will be transmitted, motion will be transmitted through the connecting rod. Once again this particular portion link 3 can oscillate about point 3, and because of this arrangement here in this we can expect we are getting certain reciprocating motion. Now this particular beam engine, I hope most of you have watched different Bollywood movies and or maybe in some Bollywood movies also, whenever there is like all those old movies where Texas etc those positions are shown, maybe you might have seen some this kind of, you might have seen some this kind of oils. Okay, some oil rigs etc, some oil you can see like oil, they are like producing oil in the Texas region and all. Okay, generally in Hollywood movies you generally see these things in background. Okay, and in the oil fields it is extensively used. Next, third inversion. Okay, we are coming to the third inversion, and one of the best example of third inversion of your the forward chain is the use this pantograph. And now what is this particular pantograph? It's a device which is used to reproduce a displacement in a either reduced manner or in a enlarged manner. Now because is as it is possible, that means we can obtain reduced manner in reduced manner also, and we can get this motion in enlarged manner also. So it is used generally for duplicating different drawings, map etc, based on whatever is the ratio at which you want to do the enlargement or you want to either reduce it. Okay, so it basically is a kind of you can say quadric cycle in the form of a parallelogram. Okay, this portion, now here it is also pivoted, and whatever tracing it does here, it gets duplicated here. And now for getting this particular ratio, if from this figure you can see it is the similar kind of thing has been represented here. The dotted line shows the different positions at different intervals. Okay, and you can see that for finding out what should be, or for getting the proper uh, what to say, the proper reduction or enlargement in this particular whatever duplication you are doing, so this is the ratio it should be followed. Okay, so based on this particular, from this geometry we can select that. Next, the fourth inversion and the last inversion of this particular scene, and this is the Watt mechanism. So basically this has been invented by James Watt for using in his steam Watt, the steam engine, for guiding the piston rod. He actually wanted that some this kind of straight line kind of thing, in a straight line manner his piston rod should be, it should move. So with various trial and error and experimentation, he has found out this particular mechanism. As he has found out this, he has invented this, so it is named after him. So in this particular case, basically link OA and this link BC, okay, they are parallel in the mean position of the mechanism. That means whenever there is no displacement, no distortion, they are parallel. At other positions, as it is evident from this particular GIF, from this animation, it may not be, it is not parallel, not may not be, it is not parallel. But whenever it is at the mean position, yes, that means it is, yes, now, okay, so it is, they are parallel, and they are connected with another link AB, which is here in this particular case the blue one. Okay, now for a small displacement of the levers OA and you can say like the BC. Okay, so the point D, which is there, the point D, it traces a approximate straight line. Okay, now from this dotted line it is evident how it is going to obtain the, or how, what is the approximate straight line. So basically later on you will discuss, we'll discuss certain mechanism, straight line mechanism. We'll see there is approximate straight line motion mechanism, there is exact straight line motion mechanism. So this what mechanism, it falls under approximate straight line motion mechanism, because you can see from this particular animation that towards the end it is deviating from the straight line towards the end, it is deviating from the straight line motion. Okay, so it is almost for from here to here it is almost like straight line, but towards the end it deviates slightly like this. Okay, but from here to here it is almost straight line only, and with this basically we can get the required straight line motion. And as it is not exactly the straight line, that's why it is called as, this kind of motion mechanisms are known as approximate straight line motion mechanism. And now which particular point is going to trace this particular approximate straight line, that we must know. Otherwise any arbitrary point if you consider in this particular AB link, it is not going to trace this particular straight line. Okay, so in that particular case this point is located on last point, you can see the point D is located on AB, such a way that this ratio AD by DB should be equal to BC by OA. Then only you can expect that point D is going to trace a straight line, or in other words, whatever you position, okay, whatever element you position at this point D, it is going to move in a straight line direction. Okay, so with this, for this particular lecture we complete here. In the next lecture we'll be discussing about inversions of some other kinematics. Thank you.